Alright, so I'll go through the solution for the quiz. You need to do them algebraically if you can, only using a calculator when it's like just the final answer or sort of like, you know, next final fraction or something, but it's also important to practice it just in case you do get it on the non-calculator section. Why is it not working? Okay, so in order to solve this question, you need to make sure everything is on one side. So I'm going to take 33 because I did take 33, and that's what I need to solve. I will use sum and product because going down the list, factorizing doesn't work, difference of two squares doesn't work because there's not two terms. Perfect squares don't work because this term is not square rootable. So yeah, that's what I'll use. 11 and 3, and one of them needs a minus, and if I figure out the sum, it'll be 11 take 3 equals 8. So that is what I will use to create my brackets, plus 11, and then minus 3. So therefore my x is going to be minus 11 or 3. Moving on, same process, make sure everything is on one side. So I did minus 56, and then I may begin. So with this one, I can't really see a common factor. This isn't difference of two squares because there's more than two terms. This can't be perfect squares because I can't square root these two terms. I could try sum and product, but just looks too hard when there's a big coefficient. So I'm going to use quadratic formula because this question doesn't specifically ask you to use a specific one. So I'm going to use that A is 15, B is 2, C is minus 56. So using the quadratic formula, I should be able to figure out my answers. 2 squared, 4, 15, minus 56, divided by 2 times 15. So if you use your brain, so I could probably use a little bit of aid of calculator here because those numbers are big. We probably wouldn't give you that big of a number and expect you to do 4 times 15 times 56. It wouldn't be that harsh. So I've just done that. If you technically put it all, it should spit out the final answer for you. Oh, that should be a plus because it's minus times a minus a plus. Which is minus 2 plus or minus square root of that is 58 and then 30. So my answer will be minus 2 plus 58 divided by 30, which is 30, or minus 2 take 58 by 30, which is minus 2. So exactly, so I can, with this one, put it on one side and use kind of the idea of perfect completing the square. So I've added 7 to this if you weren't sure what I did, and then I'm going to square root both sides. So when I square root both sides, I get a plus or minus answer. Therefore 1 take 3x is going to be plus or minus square root of 7, and then I'm going to get rid of the 1 by taking it. And then I'm going to divide by minus 3. So therefore, my answer x is going to give me negative 1. So if I divide each term by negative, there you go, so I get 1 plus or minus square root 7 divided by 3 as my answer. Question 2, solve exactly by completing the square. So they want us to complete the square now. So they want us to make it into basically that format first in order to solve it. So in order to do that, I need to make sure everything is on one side first. So I do take 8x from both sides. So I get x squared, take 8x plus 10 equals 0. Next step is to move that coefficient, or just double check that the coefficient is 1, which it is. Then you move that back onto the right hand side. So leave a bit of a gap and then move it to the right hand side. So it's important that we have x squared and x term on the left hand side and the constant term on the right hand side. And then the perfect square term that we're adding is going to be the coefficient of x, so minus 8 divided by 2 squared. And we do that both sides. There we go. And then therefore this perfect square simplifies down to x, and then minus 8 divided by 2 is minus 4, so that is my perfect square. And then the right hand side would be minus 4 squared, so 16. Minus 10 plus 16 is 6. So this is what I have so far. I just need to solve it, so square root both sides. So I get therefore x take 4 equals plus or minus square root 6. So I get plus 4 plus 4. So therefore x equals 4 plus or minus square root 6. If I write that in a symbol, yep, I'll just leave it like that. Solve exactly by completing the square again. So I've already got my x squared and x term over here. Now it is important that every term gets divided by 4. So x squared plus 4x, and then we got a minus 5 over 4 as well, because, so let me do a step so it's easier for you. Take 5 both sides. Don't want to skip steps and confuse people. If you are watching, you obviously need some support. So here we go, this is what we start with, and then we divide every term by 4 in order to make our life easier. There we go. And then if I divide both sides by 4, we can ignore the 4 basically, and go therefore x squared plus x take 5 over 4, I'll write it like this, equals 0. So this is the equation that we're trying to complete the square with. So this is where we begin by leaving it, moving it to the other side by adding 5 over 4, and then we add the coefficient 1 divided by 2 squared on both sides. That's just the rule of completing the square. So therefore x, it'll be plus half squared on the left hand side, and the right hand side would be 6 over 4. So if I write my answer, it'd be 6 over 4, which is also 3 over 2, so I'm just going to write that instead. Always like to simplify, and then we square root both sides. So therefore x plus a half is plus or minus square root 3 over 2, and then you take away half both sides. Therefore x is going to be plus or minus, minus a half plus or minus square root 3 over 2. Awesome. So before we have a fraction, so we need to make sure there's one fraction on one side. So we can make any fraction, any number a fraction. So I'm trying to add 1 over 1 and minus 1 over x. So I need to times both sides by x with this one to make sure the denominator is all x. And then I need to go x, and then you've got to go minus 1 on the numerator. And then I've got minus 5x on the other side. Remember, any number can be turned into a fraction by dividing by 1. Then we cross multiply. These get cross multiplied. So it'll be x take 1 times 1, which is x take 1. And then the other side, if I use a different color to show you, x and minus 5x will be times by using cross multiplication. So that'll be 5 minus 5x squared. Just need to make sure they're all on one side. I'm going to move this onto the right hand side so it is a positive x squared. So therefore 5x squared plus x take 1 equals 0, and that is just what I'm trying to solve. So in order to do that, I can use quadratic formula. I reckon 5b is 1, c equals negative 1. So therefore x is going to be negative b plus or minus square root b squared take 4ac divided by 2a. So that's what I need to do. 1 plus 20 divided by 10. So if I simplify that, negative 1 plus or minus square root 21 divided by 10 is what I get. Okay, use quadratic formula to solve exactly for x. So again, I need to identify my a, b, and c. A is minus 2, b is 7, c is minus 2, and x quadratic formula looks like minus b plus or minus square root b squared 4ac divided by 2a. So if I fill that in, minus 7 plus or minus 49, take 4, minus 2, minus 2, divided by 2 minus 2. You can check that in your calculator, but if you want to practice it, do it manually. 49 plus 4a 16 divided by minus 4. 49 plus 16. Okay, minus 7 plus or minus square root 65 divided by minus 4. Okay, I'm just putting in the calculator to make sure I can't simplify it anymore. Yeah, so that one will just turn into the minus cancel out. You can just cancel these ones out. And technically you will get 7 plus or minus 64 4. Okay, now we have to rearrange the following equations so they are written in the form ax squared plus bx plus c, then use the quadratic formula to solve exactly for x. Okay, so again we've got a fraction, so we have basically 2x divided by 1. Then we need to add these fractions together, so we want these denominators to be the same, so the easiest way is to times them. So times this by x, times this by x. So we have 2x squared, and then I've got an x, and then I've got to take 1 equals 3. Make that as fraction, and then we cross multiply. So this first diagonal, what just happened? This first diagonal will turn into 2x squared take 1. The other diagonal will turn into 3x. Therefore, 2x squared take 3x take 1 equals 0, and that's what we're trying to solve using quadratic formula. So a is 2, b is minus 3, c is minus 1, so therefore x is going to be looking like minus minus b, so there we go. 9 take 4, 2, minus 1, 2 bracket 2, so 3 plus or minus 9 plus 8 divided by 4, so 3 plus or minus 17 divided by 4. Done. Using the discriminant only, so discriminant is b squared take 4ac. State the nature of the solution. A is 1, b is 1, c is 5, so b squared, 1 squared take 4ac, 1 take 20, so that's minus 90. Therefore, if it's a negative, there is no real solution. For each of the following quadratic roots, find the discriminant in the simplest form. Hence, find the values of m. So this is what we're working with. So a is m, b is 3, c is 2. So our discriminant looks like b squared 4ac. If I simplify that, I get 3 squared take 4m 2, so I get 9 take 8m. This is what we're working with. For I, if I want a repeated root, I want the discriminant to equal 0. So I want 9 take 8m to equal 0. When would I get that? I would get, I'm going to move 8m the other side. I use a different colour to show you. I'm just rearranging the equation, and then just divide by 8. So therefore, m would be 9 over 8. This is when I would get a repeated root. For I, two distinct real roots, I need to have discriminant greater than 0, so 9 take 8m is greater than 0. So when would that happen? 9, it would be greater than 8m. And then I just divide by 8, so 9 over 8 is, so m is less than 9 over 8. That's when it would give it. No real roots in which when discriminant is less than 0, so 9 take 8m is less than 0. So I will get 9 is less than 8m, divided by 9 by both, 8. And then 9 over 8, there we go, m is greater than 9 over 8. So those are our answers. Show that the sum of the root is equal to the product of the roots. Remember that 2c is a hard one, but question 2 you should have done it for homework, so we'll give it a go. So we've got a plus b equals, I think from memory, negative b over a. You should have your notes hopefully with you. I'm pretty sure these are right, so I'm going to roll with it. So a is 1, b is negative 5, c is 5, looking at that. So I should be able to substitute this in negative b over a. So negative 5 over 1, 5 over 1. So that's 5, that's 5. Notice that it is equal. So a plus b equals ab because they both equal 5. Okay, so we kind of showed that. Check this by solving the quadratic. Okay, if I want to solve the quadratic, I need to basically find answers. So I need to find answers of my roots for this quadratic function. In order to do that, I need to, well, I can't use factorizing, common factors, I can't use difference of two squares, I can't use perfect squares, I can't use sum product, I don't think, so I'm going to use quadratic formula. So a is 1 for this one. Oh, it's the same formula, so I can use the a, b, and c over here, so I'm going to use that. So x must equal 5, 25, take 4, 5. Oh. Now it is important, if you can, practice your speed and accuracy, because it's something you will struggle with in year 12. It is easy to lose marks for not doing the questions because you ran out of time. Okay, so these are my solutions. I'm going to confirm them by adding them. So if I add them, hopefully I get 5. Let's give it a go. 5. So what should I write? Checking. 5 plus square root 5 over 2 plus 5 take square root 5 over 2. I can do this manually. 5 plus 5 plus square root 5 take square root 5 over 2. Well, these cancel out. I have 10 over 2, which is 5. Wow. Lovely. So the alpha plus beta equals 5. It checks out. Let's try the alpha times beta, the products. So if I times them, alright, so what happens is I need to times numerators and the denominators together. So at the top, this is what it would look like. And then the bottom would be 2 times 2, 4. Alright, so let's give this a go. So we technically have the pattern a plus b, a minus b, so I can use a squared take b squared as my difference of two squares formula. So a squared would be 5 squared, b squared would be square root 5 squared, and 4. And then we have 5 squared, 25. And then these two cancel out, so I get take 5, divide by 4, which is 20 divided by 4, which is 5. That equals 5. So we have confirmed question B. Alright, let's do a hard one, question 6. The root of the equation are alpha and beta. Find a quadratic equation with negative versions of those. Okay, let's have a go. Alpha and beta. Alpha plus beta is going to be negative b over a. Alpha times beta is going to be c over a from our formulas. A in our case is 3, b is 2, c is negative 4. So that's going to be negative 2 over 3. That's going to be negative 4 over 3. So that's what we have. So we should be able to kind of come up with, try to figure out what negative alpha plus negative alpha beta is. Let's see if we can manipulate some data. So that would be negative alpha take beta, which we can also write as a factorized of alpha plus beta. So I should be able to substitute my answer into there. So therefore it'll be negative 2 over 3, which is 2 over 3. So sum of our new equation is 2 over 3. That's what we know. Cool. Okay, cool. which is also known as negative b over a. So I kind of can already tell what a and b is, but I'll wait until I do the other one. Alpha times beta. So if we have negative alpha times negative beta, we have alpha beta. So that's the same answer as this one, negative 4 over 3. So that's going to be the same. So product of new equation is 4 over 3, negative 4 over 3, which is the same as c over a. So looking at these, I should be able to deduce my new a, b, c. So I'm going to use over here. So my a is going to be 3, b is going to be negative 2, yep, c is going to be negative 4. So all I need to do is construct a new quadratic equation using those. So y equals 3x squared, take 2x, take 4 is my answer. That's my new quadratic equation.